Hey Chem friends, this is just a quick video to cover how do you manage doing Lewis structures for polyatomic ions. How do we account for that? So that's what this video is going to cover. Let's start with a polyatomic ion, a simple one, the hydroxide ion. Step one, what is the formula? Make note of the negative charge. Step two, how are these atoms arranged? Only two atoms, pretty simple. Step three, how many valence electrons? 6 from oxygen, 1 from hydrogen is 7 valence electrons. But we have one additional electron in this ion, which is what makes it a negatively charged ion. So this -1 charge tells us we have to add 1 electron here. So we see we have a total of 8 valence electrons. This makes us happy. The odd number of valence electrons is a little weird because typically we're dealing with things in pairs, so we want to have an even number. So then we take our arrangement and we move it over here. And then you'll remember that the first pair of electrons goes between the two atoms, regardless of what the atoms are. That leaves us with 6 valence electrons in our pile here. We've distributed 2. I'm looking at the 2. Hydrogen only needs 2 valence electrons to satisfy the noble gas configuration. So I see the hydrogen is all set. So I'm going to take at the oxygen and make sure it gets the noble gas configuration by distributing 6 electrons there. So I've distributed all of the electrons. The oxygen is satisfied with 8 and it has the noble gas configuration. The hydrogen is satisfied with 2 and it has the noble gas configuration. The last thing we need to do with the polyatomic ions in the Lewis structure is to enclose it in brackets and then put the charge outside. We don't want to lose track of the charge on the ion, so we enclose the Lewis structure in brackets and show the charge out there. So there's a simple one, the hydroxide ion. Now let's consider a polyatomic ion that has a positive charge. In this case, we're going to look at the hydronium ion. So we have a positive charge here. We need to know the formula so we know how many atoms of each element are in the substance, in the particle. Then we need to know how are they arranged. We know that hydrogen can only bond to one other atom, so we're never going to see hydrogen as a central atom. So we know the oxygen is central and surrounded by the 3 hydrogens. Remember, next we want to know how many total valence electrons we have. There are 3 hydrogens. Each one brings 1 valence electron to the picnic. So that's 3 plus 6 for the oxygen. That gives us a total of 9. And then we remember, oh, wait a second, it's got a positive charge on it. That means that it's missing or is short 1 electron, or it has 1 less electron than the number of protons in the structure. So we need to subtract the 1 sort of missing electron because we don't like this odd number, we like this even number. So we're down to 8 valence electrons to distribute. So we have this arrangement of the atoms. We start by putting a pair between each of the atoms. That's 2, 4, 6. That leaves us with 2 remaining electrons that haven't been distributed yet. First, we want to check the non-central atoms. Remember, these would be the hydrogens. Hydrogen only gets 2 valence electrons to get the noble gas configuration. So it's all set. I don't want to add any more electrons to the hydrogens. There's 2 left here. Oxygen only has 6 showing. So it works out great to put that final pair right up there, which gives oxygen the 8. So now it has the noble gas configuration. We've distributed all of the electrons. None are left here in our jelly bean pile. Everybody's got the noble gas configuration. And remember, this is a polyatomic ion. So the last step is enclose it in brackets and show the charge. This charge here has to be represented in the Lewis structure. In this final segment, we'll take a look at a polyatomic ion that has elements in it other than hydrogen. Hydrogen tends to be very simple because it's only got 1 valence electron, only needs 2 to have the noble gas configuration. So it's pretty straightforward and simple to do the distribution when we have hydrogen atoms. Let's look at one that's not so straightforward. remember the first thing we need to know is what is the formula for this substance. So we're going to use chlorate for this example. This is a polyatomic ion with chlorine, 3 oxygens, and it has a -1 charge. The second thing we need to know is how are these atoms arranged. Chlorine is the central atom. And for now, let's just accept that you're being told that chlorine is a central atom. Later on, we'll learn how to determine what the central atom is. So this is the arrangement. We have the chlorine as the central atom and the oxygens as the non-central atoms. The next thing we do is total up the number of valence electrons. 6 and 6 and 6 from the oxygens is 18. Chlorine comes to the party with 7 valence electrons. So that gives us a total of 25 electrons. Remember that we get a little aware when we see an odd number of valence electrons here. There's a negative charge on the polyatomic ion, so we know there's 1 additional electron. So we have a total of 26 valence electrons to distribute. That makes us feel better. It's an even number. So we'll take this arrangement over here. And remember, we always start by putting a pair between the atoms. So that's 6. Now we're down to 20. The next thing we do is we look at the non-central atoms. I know that oxygen, to have a noble gas configuration, needs 8. So that's 6 for this oxygen, 6 for this oxygen, and 6 for that oxygen. 6 times 3 is 18. So I've got my 20 remaining. I'm going to move that up here. And I subtract 18. And I'm left with 2. Then the last thing I do is I look at the central atom. All of the non-central atoms have the noble gas configuration. I've got 2 electrons left over. Works out great to put that right there around that central chlorine atom. So I see that all of the atoms in this structure have satisfied the noble gas configuration. So there's our Lewis structure. I have to remember that this is a polyatomic ion. So I enclose the Lewis structure in brackets, and then because it's got a -1 charge, I have to show that. So there you go. Same process, a little bit longer, more electrons to distribute, but that shows you how to do the Lewis structure for a polyatomic ion.